Greetings. Today we're going to continue our lesson of dimensional analysis. But today we're going to tackle a little bit more complex problems, multidimensional problems and cubic and squared problems. This multidimensional problems are just conversion of units of 2 units, grams per milliliters to pounds per liters. 2 units are involved here. The key to remember is that each unit must be converted individually, 1 unit at a time. So a quick review here of the rules. We're going to write the numbers in fractions. We're going to write the units, all units. In fact, you're going to write the units first. The units have to cancel, and they cancel diagonally. Cancel, 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 cancel. Numbers on the top are multiplied. Numbers on the bottom are divided. Numbers on the top multiplied. Numbers on the bottom divided. Got it? Divided. All right. So let's move forward. A reminder, prefixes. You must remember some of the key ones. Kilo means 1,000. There are 1,000 of the base unit in the base unit. In other words, there are 1,000 meters in a kilometer. There are 1,000 grams in a kilogram. That you must remember. Centi means 100th. There are 100 centimeters in a meter. There are 1,000 millimeters in a meter. Micro means 10 to the negative 6. So therefore, you must remember these important units. All right. These are some of the conversion factors. You can look one up online, or you can use this one, or I will be giving you one. These are some of the common conversion factors. I am not going to flip back to them because it's a little cumbersome. So I'm going to tell you the ones that I know and the ones that you will need for these conversions. So let's start with this problem. The density of silver is 10.49 grams per milliliters, and we want to find out what that density is in pounds per liters. So I'm going to begin this problem by, first of all, writing down what am I looking for. And what I'm looking for is pounds, and I should put LBS for pounds, per liters, because that's where I want to go. And I start out with 10.49 grams. This is supposed to be a 9 grams. 10.49 grams per milliliters. So I'm going to draw my line here and put milliliters here. Now, 10.49 grams per milliliters, that means that for every milliliter, 1 milliliter of silver has a mass of 10.49 grams. That's exactly what it means. So we need to convert. I need to convert each unit at a time, one at a time. So first I want to tackle grams to pounds. So I'm going to draw my railroad tracks, and I want grams here, and I want pounds over here. If I look, I said that I wouldn't go back, but I need to show you. If I look at my conversion factors, I see that over here I have 1 pound is equal to 453.59 grams, which I can say is 454 grams. So 1 pound, 454 grams. I'm going to go back to my problem and continue. 1 pound is equivalent to 454 grams. And I know that now grams will cancel. diagonally. I have pounds per milliliters, so I must change milliliters to liters. So I'm going to say that I'm going to have milliliters here and liters here. And what's the conversion between liters and milliliters? Well, I know there's 1,000 milliliters in 1 liter. So 1,000 milliliters in 1 liter. And at this point, I know that my milliliters cancel diagonally. They don't have to be next to each other. But now notice that what I have left is pounds in terms of units, pounds per liters. So I'm going to go ahead and apply the rules. Top multiplies, bottom divides. 10.49 times 1. Of course, the 1, anything multiplied by 1 is the same number. So I can skip that step. I can say 10.49 divided by 454 grams times 1,000 will be equal to my answer, which is rounded to the correct number of significant digits, is 23.11, because it was 23.105727. So I'm going to round to 4 significant digits based on the initial number. That's what I want to base it on. And this is pounds per liters. That is my final answer. All right, very good. Now, moving right along, I have the next problem for you. This is a picture of me during the century that I did in Seattle. Well, that I tried to do in Seattle. It's a story for another day. And on a good day, this wasn't during my century, that I didn't do that well during my century, but on a good day, when I go for a 30-mile ride, on a good day, like I said, I'll average 14.2 miles per hour. And what I want to know is how many meters per second am I going? So if I'm traveling at that speed, how many meters per second am I traveling? So I am going to say, let's start out with question mark. I am looking for meters per second. I can do slashy here, but not in the solution of the problem. And I'm going to start with 14.2 miles per hour. No slashes here. Per hour. And I'm going to go from miles to meters and hours to seconds. So this is how I'm going to tackle this. If I go back to look at my chart, I know that 1.609 kilometers is equal to 1 mile. So I'm going to go ahead and write the units first. I'm going to say kilometers over mile, because I want to get rid of miles, and I want to go to the from the English system to the metric system. So this is the conversion that I know, and I know that 1 mile is equal to 1.609 kilometers. And this is, where did I get this? I get it from the conversion chart. And I know that miles will cancel out. So right now I'm at kilometers per hour. But I want to be at kilometers because what I want is meters. So I need to convert kilometers. So I'm going to put kilometers down here. And I want to go to meters. And I know off the top of my head, like you do, that 1 kilometer is equal to 1,000 meters. So keep going, because my problem is not done yet. So what am I going to cancel out now? Kilometers cancel. Diagonals cancel. I am at this point at meters. per hour. Where I want to be in meters, but I want to be in hours, not hours, but seconds. So I have to convert now hours. Remember I told you one at a time. I want to convert hours to seconds. And I don't know the conversion, the direct conversion from hours to seconds. I don't know how many seconds are in an hour per se. I sort of do, but we're going to do it this way. And I'm going to go ahead and say that 1 hour, in other words, I know that we're going to put hours up here, and I'm going to go to minutes first. So this is minutes. I know that 1 hour is equal to 60 minutes, and I'm not there yet. I need to go to seconds, and I know that 1 minute is equal to 60 seconds. So now let's see where we are. I'm going to cancel out hours, and notice that they don't have to be next to each other. They just have to be diagonal, hours to hours. And I'm going to cancel out minutes and minutes here. Notice what's left now. Meters, seconds. Am I there yet? Like the kids used to say in the car? Yes, I am. So now I just have to punch in my numbers, and it is 14.2 times 1.09 times 1,000 divided by 60 divided by 60. And this gives me my answer, which is, if I'm not mistaken, if I wrote it correctly here, 6.346611, which I need to round to 3 significant digits, which means it would be 6.35 meters per second. And I can do slashing now, but not during my problem solution. All right. So all I have to do now is box in my answer and make a better box than that. Okay. And that's it. That's how it works. All right. Let's move on to the next one. All right. All right, now this problem is a little different because we're working with cubed figures or cubed units. So let us begin with question mark. What am I looking for? I want inches cubed. Now I'm going to do this in the simplest way. If you can do this in the more complex way, as long as you continue to do it in with significant digits, I'm going to do it in the simplest possible way so you see that you will not make a mistake this way. If you can do it more complex, fine, as long as you use dimensional analysis, be my guest. I'm going to do it in the simplest way possible so that everyone can understand it, and people like me who need things in the most simple way, presented in the most simple way, can get it, because I'm one of those. So we're going to start out with what we know. I have 730 centimeters cubed. And I'm going to draw my railroad tracks. Okay, and I kind of did it lopsided so that I could write not on the cube over there. And I'm going to start out with, here, I'm going to rewrite this again because I want to do it in a different way. So I'm going to write 630 centimeter, centimeter, centimeter. That's centimeters cubed. Right? Now, I know that I need to convert from centimeters to inches. I need to convert from cubic centimeters to cubic inches. But the conversion that I know is single dimensional. So in other words, I know that 1 inch is equal to 2.54 centimeters. Now, I just happen to remember that. You will too once you do 10,000 problems like I have. So, or maybe less. All right, so this is the deal. I'm going to convert 1 inch. So I'm going to set this up. Let's do the units first. But I want inches cubed. So I'm going to have to do inch, 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 because I want inch cubed. And I'm going to have to do centimeters, 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 because I want it cubed. And I know that I have 1 inch is equal to 2.54 centimeters. Draw my line here. And 2.54, 1 inch, and 1 inch, 2.54. So I am ready to cancel out units. Centimeters cancel centimeters. Centimeter cancels centimeters. Centimeters cancel centimeters. And I will end up with cubic inches. Inch times inch times inch. So how do I solve this problem? 730 divided by 2.54 divided by 2.54 divided by 2.54, and my answer comes out to 44.54. So I'm going to round to 2 significant digits, which will make it equal to 45 inches cubed. Sorry, cubed. 3. Cubed. Because it's 3 times. That's it. That's it. That's all there is to that problem. All right. I'm going to let you try this one and see how that goes. Pause. Try it out on your own and see how well you can do with this particular problem. But I'm going to solve it for you. I'm going to try to do it rather quickly. I don't want this to go on forever. And I'm going to start out with question mark. Question mark. What am I looking for? I am looking for millimeters cubed. I start out with 3.25 feet. Feet. Is it foot, or feet? I don't know. Foot. All right. So I'm going to start out there and draw my. Probably not enough room there, but I'll work it out. So I know that there are 12 inches in a foot, and I know that for a fact. So what I'm going to do is I'm going to convert to something that I know. I know inches to centimeters, and then I can go to millimeters. I don't know feet directly to change it to millimeters. So I'm going to say 3.25, 50 feet, foot, whatever. And I want to cancel out foot for foot. So I'm going to say foot. Oh, that's too close. Oh, no, I don't know what I'm going to do with that. All right, so I'm going to say 12 inches. Because I know there are 12 inches in a foot. 12 inches and 12 inches. Okay. All right. Oops, sorry. I didn't mean to do that. All right. So I have 12 inches, 12 inches, 12 inches. And now I know that foot will cancel out. Foot cancels foot. Foot cancels foot. Foot cancels foot. and I have inches, inches, inches at this point. Now, I can't use inches because what I want is millimeters. So I'm going to go first to centimeters because I know that conversion. I know that we just did that, 1 inch equals 2.54 centimeters. So I'm going to say centimeters, 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 to inch, inch, inch. Do it once and then repeat it 3 times. And I know that there are 2.54, getting a little messy here, 2.54, it's so hard to write with this pen, and look at the screen. 1 inch, 1 inch, 1 inch, and I'm going to draw my lines here like this, and I know that at this point, inches, 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 they cancel. I am at centimeters cubed. Now I have to go from centimeters cubed to millimeters. All right, so I got to draw another line because I don't have enough room. And just continue from where you are. And now I know that I have to get rid of centimeters. So I'm going to put centimeters, 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 and convert each centimeter to millimeter. Millimeter, millimeter, millimeter. I know that in 1 centimeter, there are 10 millimeters. If you don't believe me, go look at a ruler, a metric ruler, or a meter stick. There are 10 millimeters, 10 millimeters per centimeter, and 10 millimeters per 1 centimeter. Now, coming back over here, I can cancel centimeters, cancel centimeters. Let's draw our lines here. Centimeter cancels centimeter, and centimeter cancels centimeter. And my final answer, I'm going to have millimeters cubed. Millimeter times millimeters times millimeters is millimeters cubed. So now, how am I going to solve this? 2.25 times 12, because this is 1 here, 1, times 12, times 12, times 12, times 2.54, times 2.54, times 2.54, times 10, times 10, times 10, and my answer comes out to, and I'm going to put it in scientific notation, 1.96 times 10 to the 7th. And my units are going to be millimeters cubed, which is what I wanted from the beginning. There we go. That's it. That's the answer to that problem. So that pretty much explains the problems that we want to tackle today. And I'm going to show you this one. And I want you to, if we have time, I don't know how long this video is at this point. I will check it out. I don't want to make it excessively long for you. But I'm going to ask you to pause at this point, and then I'll show you the solution.